flight schedule object that we create in our main method right at the top of the entire method right here. So this class, this object that we create, has two major responsibilities. The first responsibility is to hold the data attributes which are application-wide. They are needed by the entire application. For example, when we set the clock, the information that the user enters for the clock is stored in the current time. We also maintain, together with the military style time in range from 0 to 2359, we also maintain the current day, and it ranges from Sunday to Saturday, and we just store a single character code to indicate the date for specific time. Of course, some of the flights in our flight schedule can cross the day boundary and run to the next day. So that's why the departure can be on Sunday and arrival could be on Monday, and so forth. So part of the data attributes that we maintain is also a list of airlines. You can see that here we have array list of the airline class type, and so that's the list of the airlines. We also have a hash map that maps the flight numbers together with airline code to the flight objects. So this is for us a demonstration of a hash map, which is a container that contains the keys and values, and we will talk more specifically about this hash map when we cover our second presentation related to Java collections and generic classes. So for now, it's just a collection of flights, right? So this is the first responsibility of our flight schedule. Hold the time, hold the day, that is also the current day, hold the list of airlines, and hold the list of flights. So this is the list of flights that implements the entire flight schedule. And the second responsibility of the flight schedule class is to provide these major methods that allow us to implement the tasks that correspond to our menu entries, so that basically holds together all the application logic for each of these use cases that we have in our application. So to talk about the rest of the application, I have created a design diagram right here that indicates how all classes are structured in this application. So we have a list of classes pretty much on the list of the source files right here. So we already took a look at the flight schedule and the menu, but we also have the airline, the departure and arrival information. We have the flight, and those are three other business objects that we will have to discuss before we explore the rest of the flight schedule methods. So let's start with the flight schedule. So in this design diagram, which is a class diagram, we have our class flight schedule displayed as a box. And right here, I just display current time, the list of airlines, right? So this is an array list, and the hash map that's called flight map, which basically stores references to flight objects. In a diagram, when you have collection of airlines, in the diagram, I'm showing you this connection, this association between the flight schedule and, in this case, an airline object, that we have a collection of airlines. And basically, in the diagram, we just use this association that this collection of airlines inside the array list has references to all airline objects in our system. But here we use an asterisk. This little asterisk right here indicates that there could be many airlines added to this collection of airlines. So in other words, flight schedule has a collection of airlines. This is what this association indicates in our diagram. The second very similar association between the flight schedule and the flight is that we have a flight map which stores references to flight objects, and of course these too can have multiple instances of flights. So the flight is scheduled for a specific airline, so this is why there is this association from the flight to the airline. Basically the flight stores the reference to the airline object to which this flight belongs. In addition to this, the flight has an internal flight number, which is an integer. It has the flight status, such as scheduled, departed, arrived, or cancelled. It also has the character for the type of the flight, which can be domestic or international. And it has two more references to two other objects that call departure arrival information. So for each flight we have to store departure information and arrival information. So it's done with the same kind of objects. That's why this association here between the flight and departure arrival info indicates that there are two instances of this type of object for each flight. Departure info and arrival info, these are just references to this type of object. And so both departure and arrival capturing day of the week, time of departure or arrival, the airport code, and the gate at the airport. Okay, so this information is here. As we already discussed earlier in the description of this project, we could potentially have an aircraft class defined, and we could even define more types of aircraft, like cargo aircraft, passenger aircraft, and so forth. But this is not part of the actual implementation, and this is not required in this project. We said earlier that the airline will simply hold the information about the aircraft name, the model of the aircraft, and the capacity for different class seating. Okay, so that is all built into the airline. So once again, we only focus on the schedule, which is just one instance of this object exists in the system. We have a collection of flights and we have collection of airlines, and each flight has two objects referencing two objects that indicate departure and arrival information.